In the first part of the lab, we built code that drew the sine function using spaces and asterisks. Now we'll build on that to make a more interesting graph. Now we want to draw a graph that colors the area between the cosine function and the sine function. Don't worry if you don't know what they are. You just need to know their shapes. We learned in the last lab that the sine function of pi is 0, and that it goes down to -1 and cycles between there and +1. So you can see here the sine function is on one side of this shape. Cosine is the same kind of curve as sine, but the cosine of pi is -1. The blue line here is the cosine function, and you can see that the graph that we want to draw puts asterisks between the sine and the cosine at each row of our graph. In order to do this, we're going to have to change the way we print a line. In the first lab, we built a method named printBar that printed out one line. We're going to have to replace that with a more complicated method to make it color between two values. So, we want a method that takes two heights, measured in the number of spaces, and colors the area between them with asterisks. The variables sine and cos will hold our current sine and cosine values, and we're using the existing calculate height method to convert those real values to spaces. So the two arguments to print between two bar are the number of spaces to the sine and the number of the spaces to the cosine. To color between the two values, we want to print spaces to the smaller one, then print asterisks to the larger one. Sometimes sine is bigger and sometimes cosine is bigger, so we'll have to figure out which one is smaller first, then print spaces to the smaller one and asterisks to the larger one. Here is the declaration of our method. Notice its return type is void because it doesn't give back any information. It has two integer parameters that are the two heights of the functions. In order to figure out which is smaller and which is larger, we use the methods Java gives us. Math.min takes two arguments and evaluates to the smaller one, while math.max takes two arguments and returns the larger one. So our variables min and max will hold the smaller height and the larger height respectively. This method uses an integer variable named I to keep track of where we are in the line. I starts at 0, the 0th character on the line. This loop will print out spaces and increment I until I gets up to min. Then we print out an asterisk and increment I to count that spot. That ensures that even if the two heights are equal, we'll print out at least one asterisk. Then this loop continues to increment I, but now we are printing out asterisks because I is between min and max. When we finish, we print out one more asterisk. Now the minimum asterisk in the line is 2, and that matches the 2 extra characters our header added to the width of the graph. Print line moves the output pointer to the next line.
You should practice being the machine and put a few different pairs of values into H1 and H2 to make sure you know exactly how this works.
To use that, we just have to modify our main method to calculate the cosine of H, and then call print between two bar where we used to call print bar. Now the graph is doubly curvy. So, there are a bunch of reasons why we create methods. The first, it makes our code more readable. That's true if you name the method well. Methods generally are doing something, so their names usually start with a verb, like ours started with print or calculate. Second, methods make it easier to solve problems because we can solve smaller problems and then put them together to solve bigger problems. Third, when we put code in a method, we can call it from multiple places in our code. In this part of the lab, we called calculate height in two places, once for the sine and once for the cosine. Imagine how ugly that code would have been if we had had to put those two calculations in our main method twice.
You really care a lot about how readable your code is. If we had wanted it to be readable, why did we call it code?
Ha! That's funny. Readability is one hallmark of good code. When you write a lot of code, it's hard to remember everything you did and why you did it. So even if you're the only person looking at the code, you still need it to be readable. And software engineers usually work in teams where no one owns parts of the code. Today you might be writing the code that accesses the database, but tomorrow one of your teammates might have to add something to that code. They want it to be readable, and you want their code to be readable so that everyone can safely add to the system.